Hey everyone, welcome back to the channel. Today is a big one. Luma Shapes is officially live on the Google Play Store. Yeah, I did it. I actually shipped a game. And look, everyone loves to talk about how brutal it is to code a game, the late nights, the scope creep, the existential dread at 2 a.m. when your shader breaks for the 47th time. But nobody warns you about the true final boss, federal tax forms, and Google's compliance dashboard. Now please give me a chance if you're planning on making your own game or game dev curious. This video is going to cover the real hard fact of dealing with this rather dry topic. Don't fret, I'm going to do my bony best to keep it fun, so stay locked in while I yammer on about how I combine Godot with a bunch of AI art tools as a solo dev, survived the bureaucratic maze, and actually got the game out the door. Alright, let's talk about the part nobody wants to talk about, becoming a legal entity. Because here's the thing, if you want to publish like a serious developer instead of some random indie dev in sweatpants, Google wants you to be a real business. And the biggest key to making that process less miserable is getting a DUNS number, D-U-N-S number. It's basically a 9-digit fingerprint for businesses worldwide. Google uses it to verify you're not some fake account. And here's the hidden golden nugget that made this whole thing worth it. If you set up a verified organization account with a DUNS number, you completely bypass Google's annoying closed testing requirement. If you're not aware, your personal account has to have 12 plus testers playing your game for 14 days straight before you can go live. That can be a hurdle if you're an introvert with no friends. Thankfully, the organization route lets you skip that gate entirely and go straight to production. A literal game changer. Okay, so how did I actually make the game? I chose Godot, and I think it was the right call. It's lightweight, it handles 2D pixel art pipelines beautifully, and it didn't try to fight me every step of the way like some other engines I've used. On the art side, I went pretty heavy into AI tools. As a solo developer, I used Gemini to help with conceptual scripting and structure, VO for generating video foundation for the cutscenes, and the amazing Higgsfield AI to turn those into proper pixel style animation. It let me get a much higher production look than I ever could have done by myself with traditional tools. And yes, I'm fully aware some people have strong opinions about AI art, but I'm just a one-person team trying to make something cool without needing a whole studio budget. After all, this is a free game for babies. There is no budget. So let's talk about the actual game feel, because this is the part I'm genuinely proud of. Luma Shapes is built around interactive audio meeting dynamic visual. Every single level background is procedurally generated using fragment shaders instead of massive static image files. This keeps the game tiny while still looking fluid and alive. I also mapped button coordinates directly to specific synthesizer audio streams, so when you play, you're literally playing the shader. The math and logic behind syncing the visuals with the sound was one of the most fun and occasionally sanity testing parts of the whole project. Again, this is a sensory game for small children, which I chose because this was mostly designed to be a learning experience for me and the ability to add published Android developer badge to the old resume. I've talked about this in another video, but I just want to give another shout out to the Godot Shaders website. There are so many amazing shaders that you can adapt and tweak to get the exact look and feel that you're going for. It's a great starting place for adding really cool backgrounds, textures, however you want to take advantage of these shaders. For me in this game, it was all about making cool backgrounds that you were able to interact with when you touch the screen or another UI element. It was really easy to tie in interaction events from the background to the UI elements or the user input, something that you would never be able to do or not do very easily if you were using static images. Before we touch on the equal parts important and dry topic of actually getting your app in the Play Store, I want to break out and down some of the code that makes this app sing and dance. So stick with me while we geek out a little and look under Luma's hood at the code engine powering it. Let me show you one of the stars of the show, the Deep Space Liquid Shader. This is a single Godot fragment shader, one file, about 150 lines, that draws the entire animated background you see on the first level. It's also featured later with a few modifications. This gives gives the level a totally vibrant, interactive background with no giant sprite sheets, no performance-killing image sequences, just math doing cool stuff in real time. Here's what's going on. First, it creates a nice deep purple to blue vertical gradient so it feels like you're floating in space or maybe underwater. Calm but not boring. Then it defines 3 metaball style blobs. Think glowing, gooey, living shapes. Each one moves on its own path. One does a lazy figure 8, one orbits, and one bounces diagonally. They're all animated with simple sine and cosine waves multiplied by time times time beat. Classic procedural animation. But here's the really fun part. They react to your finger. I wrote a little helper function, get repulsion, that takes the blob's current position and your touch position, adjusts for aspect ratios so circles stay circular, and gently pushes the blob away. It's subtle. I tuned the strength way down because I wanted it to feel playful, not chaotic. There's even a max offset clamp so the blobs don't fly off the screen like scared cats. Then comes the metaball magic. For every pixel on the screen, the shader calculates the distance to all 3 blob centers, adds up their influence fields, and uses smooth step to create these beautiful glowing edges, soft bodies, and bright little white hot core. The colors blend between hot pink, cyan, and lime, all controllable with uniform. The whole thing runs crazy efficiently and keeps the game under 55 megabytes. That's the power of Godot Shader. Now, when you actually tap those blobs, that's where the other big part of the script comes in. Sensory effects. This thing is the feedback king. Every time you hit a shape, it spawns a little particle explosion, those fluffy cotton candy looking bursts, picks a color from the level's palette, and fires off the right sound. It handles everything from intensity scaling, more clicks equals more particles, to proper cleanup with nice fade outs using queens. It also talks to my sound manager to pull the correct lullaby style notes or upbeat sounds depending on the level. So when you're playing, you're not just watching pretty math, you're actually playing the shader in real time. The buttons trigger both audio streams and push those goo bobs around. That tight sync between visuals and sound is what makes the game feel magical instead of just another mobile toy. In my opinion, this format could be used for something like a turn-based game's battle screen background, or if you need a trippy visual element that reacts to the environment or user input. Once you get the hang of these shaders, you'll find places to put them. Trust and believe me on that. Hopefully this brief overview has given you some ideas on creating interesting and interactive backgrounds using math and not relying on sprites. And seriously, check out GodotShaders.com. Their website is an amazing resource for this stuff. There are so many cool shaders on there, you'll get lost for hours. Without all these shaders, my game would be really boring, so I can't thank them enough for all the hard work that has gone into that site. And it's totally free offerings. Okay, next up is the pile of documents shaped elephant or elephant-sized pile of documents in the room. Either way, we're going to be talking about the Google Play console and everything you need to do to get through the most banal, boring, brevity-lacking, bureaucratic, briefcase-bringing bit of business. Alright, now for the part that made me want to throw my laptop out the window, the Google Play console. When I first opened up that dashboard, I felt like an astronaut who'd never been to space, just flipping random switches and praying the rocket didn't explode. So here's the step-by-step breakdown I wish I'd had. Phase 1, identity. Developer account verification. This is where you upload your DUNS info, verify phone numbers and emails with one-time passwords, and submit your business corporation documents. Again, the prerequisite to this is already having gotten your DUNS number. You have to go to the DUNS website and it takes up to a month. You have to submit the same documents there, and it is a bit of a hassle, but overall it was a very painless, just time-consuming process. So phase 2, app setup. The big checklist. You answer questions about app access, no password lock stuff or testers, they can easily get into your app. You do the content rating questionnaire, and you set your target audience. Phase 3, data privacy. Data safety section and ads. You declare exactly what user data you collect, in my case almost none, and fill out the advertising ID declaration. Phase 4, store presence. This is the fun part. You upload your 512 by 512 pixel icon, the 1024 by 500 feature graphic, descriptions, and all of your screenshots in both 16 by 9 and 9 by 16 formats. I actually had a lot of fun with this part. There are a number of templates, and if you just browse a couple Play Store listings, you can get some really great ideas for what you can make yours look like. Personally, I really love when you you have half of the screenshot on one panel and then it continues over to the next panel. And so that's the look that I went with mine, but you're free to obviously do whatever you want, whatever makes you happy. Finally, we get to phase 5, the launch, the production track. You pick your countries, set up play app signing, and upload your AAB file, write release notes, and finally hit roll out to production. It's a lot, but once you've done it, it stops feeling like black magic. There are a couple new things like automatically doing the production publishing, and this is also if you were a single account where you would have to manage your testing tracks, your internal close testing, and having the 12 testers for 14 days requirement stuff. That's where all this would take place. This was a little bit tricky, but once I played around with it, and I think if you just spend a little bit of time in here, you'll see what they want from you and be able to get your app published. Alright, that about wraps it up for this video. Publishing a game is legitimately a massive achievement, so don't let the administrative stuff scare you away from finishing your dream project. If I can do it, you can too. My advice would be to get a start on the administrative stuff before you get to the end of your project. So if you could, go download Luma Shapes if you haven't already, leave an honest review, good, bad, or brutally honest, and let me know in the comments which shader background is your favorite. If you enjoyed this behind the scenes look, drop a like, subscribe, and hit the bell so you don't miss the next one. Thanks for watching. I'll see you in the next video. Now, if you'll excuse me, I'm gonna go stare at my analytics page like a proud but anxious parent.